Okay. So welcome to today's class, which we are just about starting. CIT735, Application Software Design and Multimedia. And so today now we'll be talking about interactive multimedia and metadata. As usual for today, we'll just cover 2 classes and see how far, so that it will be as if we have covered 4 classes so far, because each of our classes is supposed to last for a maximum of 1 hour. When we are teaching, it should be 1 hour, nothing more than that. So if we are going to take 2 hours, it means we are taking 2 classes simultaneously, and we all know the reason. Well, because the first 3 weeks, we missed out on all the classes. So even if we finish the 2 classes today, we are now going 1 more class, so that we are now in line. A total of 8 classes will be covered, for the class. So if we have taken 4 today, it means 4 more classes, which is end of this month. We are done with the course, and then we start preparing for your exams. So like I mentioned, this is interactive multimedia and metadata. That is the topic we are about starting. So at the end of this particular class, our objective is that you'll be able to define what an interactive multimedia means, and also what we mean by metadata at the end of the class. We should also be able to explain the benefits of interactivity to multimedia applications. Then 3, describe the various components of interactive multimedia. 4, understand the issues in multimedia systems. 5, give the components of a multimedia system. And 6, explain the trends in multimedia system. When you say something is interactive, I think it is engaging. It is something that you could maybe talk to. It talks to you back. Give a particular input, it gives you an output. It's as if you are engaging in conversation. And when you say someone is interactive, then that means the person is lively and very, very okay in terms of conversation. You are talking, the person is replying, not evasive, keep quiet, and doesn't say anything. An interactive class is a class whereby both the teacher and the students, back and forth, they are learning from each other. Either the teacher will ask questions, the students will respond. Students will ask questions, the teacher will respond. Then that particular class is interactive. If throughout the class, teacher does not ask any question, no student speaks at all, nothing was heard from any student, that is not an interactive class. So interactive multimedia implies allowing an end user some control over what element to present and when. It means you are actually engaging, trying to host. We are talking, I will tell you what to do, then you will know when to do it next, like that. So it allows users' responses to alter the way the presentation proceeds. For someone to truly learn how to use a program or a product, it is essential that they actually use it. That is true. For you to even learn how to drive, how to maybe drive a car, it is essential you actually enter that car and drive it. If you keep on looking at the car, oh, this car is very fine, I'm learning how to drive it, and you don't actually enter that car to drive it, you will not be able to drive it. So even if you go to a driving school and learn everything about that car, you still have to enter the car one day and drive it. Then that means you have started driving it. Otherwise, the car will just be there looking at you. So interactivity allows each user to actively participate in the viewing process instead of passively watching the material presented. For example, you have a television you are watching. The program comes the way it wants to come. You don't have any control over it. That is not interactive. But you are watching a video player, maybe watching a video through a DVD player. The way the program proceeds, you can rewind, you can fast forward, you can pause. You can decide when to play or not. There is some form of interaction between you and the program. That is interactivity. But for a television, you don't have any control over it, or even a radio. So it is what they present to you, you take. That is not interactivity. So the nature of your material determines the amount of interactivity you should use. The desktop computer is currently a popular vehicle for interactive multimedia presentation. So what do we mean by interactive multimedia? It is an integration of relationship between multimedia and interaction. It is a multimedia system in which related items of information are connected and can be presented together. A multimedia, multiple media system in which items of information that you are going to present are related, they are connected, and then they can be brought out together, as the case may be. Interactive multimedia involves combination of the following: knowledge and information. That is, whatever concept you have to present must be a concept that contains knowledge and will be able to inform people. A collection of technologies are there that will help do the presentation. Then a collection of multimedia components, channels of communication or media, a set of collaborative systems, and virtual environments. They are all brought together. Knowledge and information can be the television program. Collection of can be the computer program, sorry. Collection of technology can even be the computer itself, the computer machine itself. Collection of multimedia components can now be channels of communication and medium, can be the way these particular programs are presented. How are they presented? Are they maybe presented through wired means or wireless means? A set of collaborative systems. You have a printer, you have a, how do I call it? A floppy disk drive, a hard disk drive, all of them. All these systems are collaborating together. Then you have an internet modem that helps to move everything out. Then virtual environment, the environment it is being presented to you, will look as if it is real, but it is not real because it's coming from far. But the television will look as if everything you are presenting or the computer actually is inside that computer. But meanwhile, it is being driven from outside to where you are. So you could call it interactive multimedia. So for example, a computer video game can be an interactive multimedia. The video itself, that is the game itself, contains knowledge and information. That is everything about the script, how it was written before it goes to the end, was knowledge or information. Collection of technology, you have the computer itself, you have the video machine that was used to film it, you have several other technologies that came together, audio recorder, that were used in producing that particular film. Collection of multimedia components could be the modality, channels of communication. The player has a way it can stream the information from the video cassette itself, or the video, the DVD-ROM, up to the television. It will come out like that. A set of collaborative system. The video was supposed to be the what is playing, but it has so many systems that are collaborating together. You have a speaker that you can increase or reduce the volume. You have a remote control you use to control. These are collaborative systems that are working together to make sure that that particular knowledge and information is sent to you. Then virtual environment. So two people are fighting inside the machine. Where they were fighting was far different from where you are watching it. It might have been recorded somewhere in the United States, but the environment being presented will make you look at it as if it is actually happening there. And so when one person is beating the other, you can quickly pause the game and say, no, I don't want to endure this torture again, as the case may be. So everything put together is what you refer to as interactive multimedia. Interactive multimedia is a type of collaborative media and refers to media that allows for active participation by the recipient. If the person watching that particular video game does not take part in either altering or ordering the course of the video presentation, there will be no interactivity. He could pause it, he could rewind it, he could record it, he could fast forward it. That is interactivity. He has some form of control over what is being presented. So traditional information theory would describe interactive media as those media that establish two-way communication. Television establishes one-way communication. Radio is one-way communication. They present what you want to see or hear, but you cannot respond back immediately. The field of human-computer interaction deals with aspects of interactivity and design in digital media. And so it has gone a step further. From the video game, we now have computer programs that can simulate interactivity. While things are going on, you, the user, can actually control the sequence of events that take place within the computer. Other areas that deal with interactive media are new media art, interactive advertising, and video game production. Interactive media are often designed by information designers, and they rely on communication. So in the case of computer games, this may be visual, you are watching, acoustic, you are hearing, haptic, you are feeling, between the computer user and the game. And so you will now ask yourself, what do people enjoy when they watch video game? They play computer game. Of course, it is the interaction. Oh, I'm playing a game which is a Barclays Premier League, simulating my team, Arsenal and Liverpool, Arsenal and Man City. Because I know how to control it well, I'll make sure that throughout that particular game, Arsenal wins all the 38 games for the season and they remain top of the league. That is virtual. But on the replay, the one they are playing in the various stadiums, Arsenal may be beating, they may beat some teams, they may draw. But in your own game, you are making sure that Arsenal wins all the 38 games and they get the entire 114 points, complete, nothing short. That is because you are in control. You are the one ordering the sequence of events. Mobile telephony, that is mobile phones. The communication happens between two people and is purely acoustic at the first glance. It has to do with sound. Yet, according to media theory, the cultural implication of the media has to be taken into account. So, constant availability, the phone is always there. Customization of the mobile phone and short message services are also part of the interactive medium called mobile telephony. You send a message, somebody replies immediately. Two-way communication. You call the person talks to you back. And as the person is shouting, it affects your mood. You shout, it affects the person's mood. You send message of love to that person, it affects the person's mood. The person starts behaving normally. And when the person responds, your tone comes down. They can also send bad news to you on phone. Immediately, the person will have high blood pressure or heart attack. So that is interactivity. It affects the mood, control over the person and the other person, as the case may be. So you could also hear a message on the phone telling you, you have just won 200 million naira, and it is a fact. Instantly, all the feeling of depression you have been having since yesterday will automatically disappear. Or that contract you have been looking for, they just called you that they've offered you, or they're giving you employment in a highly lucrative company. Immediately to change your mood and you become someone different from what you were before. That is interactivity. So let's look at the components of interactive multimedia. They include the following: asset, information, and knowledge. What is an asset? An asset is an object that contains a single piece of media, like a video, a sound clip, or a graphic. Information is the collection of data by a particular encoding, and knowledge is the interpretation and understanding of information. So when you look at the components of interactive multimedia, for example, a video game, the asset will now be the video itself. The video itself that is recorded, that you want to play, that is inside a DVD. The information will now be the collection of data that is already included inside that video. Video is the technology that was used in housing that information. And then when you now open that particular information, you will interpret it and understand it, and that now gives you more knowledge, as the case may be. So those are the components of interactive multimedia. Do you have any question?
No, sir.
Okay. Excuse me. Metamedia. Metamedia. When you hear meta is something about something. So metamedia refers to new relationship between form and content in the development of new technologies and new media. Metamedia utilizes new media and focuses on collaboration across traditional fields of study. And it refers to the theoretical effects of mass media and focus on provision of flexible online environment for creating and sharing rich media documents for learning on core humanity subjects. So let's see what we actually so when you are talking, okay, components, metamedia, new relationships between form and content. Content here means what is inside. Form means how it is supposed to be presented. So even when you are developing new technology, you think about the content, no problem, what you are going to record. Form, how is it going to be? Is it going to be in form of video? Is it going to be in form of maybe a kind of DVD that is, how do I call it now? You were able to compress it so that you contain more data. So for metamedia, what it does is that it is utilizing new media technology like DVD, Blu-ray, and the others, and focuses on collaboration across traditional fields of study. Used in multimedia system. A multimedia system is a system capable of processing multimedia data and applications. So when you say a language system, it could be a system that is capable of allowing you to process a language, be able to represent it in any form that will aid communication. So when you are talking about a multimedia system, you are talking of any system that is capable of processing your multimedia data and applications. And it is characterized by the processing, it has to process, storage, it has to keep it somewhere, generation, it has to generate it, bring it out, manipulation, you may alter it, update it, add to it or remove it, and rendition, present it. That is what you mean by rendition of multimedia information. It is characterized by the processing. It has to interpret it. That is what you mean by processing. The way it is presented, it is on video. The various technologies that are on that particular device will be used to now bring out the video, interpret it, and bring it out so that the pictures and the audio will now be shown to people. It can be stored. You have a DVD disc that is storing it. You can generate it. That means you can bring it out anytime you want it. Manipulate. You can look at that video, find a way of altering the content, maybe moving it forward, moving it backwards, pausing it. Just find a way of manipulating it so that it may not have a smooth flow. You are now in control of it. Rendition, you can present it in various forms. You can say, okay, I don't want the pictures to be showing. Let it be only audio. You can do it that way. Or you can have only pictures without audio, as the case may be. So all these ones are what you call maybe the components, what the issues you have in multimedia systems. So let's look at, if we can, talk about the characteristics of multimedia system. What are those qualities? What are, qualities that a multimedia system could have, attributes? It has 4 basic characteristics. Number 1, multimedia systems is that one now with the noise. Are they bambo? Switch off your audio, please. Olalekon.
Off it now.
It's still on. Okay, off. Multimedia system must be computer controlled. What it means is that anyhow you design it, a computer can always be used to control everything about it. Multimedia systems are integrated. That means when you say integrated, it means you have multiple systems coming together to make it up. You have audio, you have video, you have text, you have pictures. They are coming together. So they are separate medium, but you are bringing them together. For instance, has it not occurred to you that maybe to look at what makes up a video that normally plays on your device is actually made up of two components. The first one are pictures, still pictures, and the second are audio. Two different systems that are recorded together. So what you see as a video actually is the capture of still photograph at the rate of 120 frames per second. That means in a second, 120 pictures have been captured, and they will now be erased serially. When the computer passes through them, it will look as if the movement will be simulated. So in 1 second, about 120 shots would have been taken. A separate system will be recording the audio. Then when they finish recording, when you now want to play back, a computer algorithm will go to the beginning, pick the video, the pictures where they started recording from, and the audio where it started playing from, and play them together. If there's any mistake, you could now see the audio speaking and the voice in the video is not in consonance. That means there's a problem. If it's in consonance, as the voice opens, the audio comes out immediately. They go together. Two separate systems, but they work in harmony. So the information they handle must be represented digitally. When you say digitally, it is capable of being kept inside the computer. All information is only in the image or video. So the interface to the final presentation of media is usually interactive. Query by example is best access method. Editing of media is almost always offline. You cannot edit it while it is playing, but you can edit it after it has finished playing. You can go back and say between 22 seconds, 0.01 seconds and 22.05 seconds. I don't like the video. You can alter it, cut it out. That is, edit it out, it will go. But while it is playing, you can query. You can pause. Query means you could ask questions, or you can send some questions to it, in this case, or some requests to it. I think that is the right word. Some requests to it that it can respond. You can say pause, it will pause. You can say fast forward, it will fast forward. You can say rewind, it will rewind. You can change the contrast. You can increase the audio, you can reduce the audio, as the case may be. You are already interacting with the system well. Challenges for multimedia systems. Supporting multimedia system. Supporting multimedia applications over a computer network renders the application distributed. This will involve many special computing techniques. Multimedia systems may have to render a variety of media at the same instant, a distinction from normal application. When you say supporting multimedia application over a computer network, it makes the application to be distributed. Why do you call it distributed? Because over the computer network, you have different kinds of computers, different kinds of media that will receive this multimedia system, format them, and play them according to the format that is okay by them. So the computer system doesn't have any control. The multimedia system does not have any control, but the computer will now have control over it. Challenges for multimedia systems. There's a temporal relationship between many forms of media, video and audio. There are two forms of problems here. Sequencing within the media, what I just said before, playing the frames in correct order or time frame in video. That is one. Synchronization, intermediate scheduling, video and audio. Lip synchronization is clearly important for humans to watch playback of video and audio, and even animation and audio. So when the lip is moving, the voice also moves with that lip. If it does not, then there's no synchronization. And then sequencing means at the correct time when it's supposed to start playing, play them together so that the two frames do not overlap. They are moving at the same pace. So the lip synchronization will move very well as you are playing the video, and there will be no problem. So those are some of the challenges we have in multimedia system. Even as much as we try to handle them, some of them still come up. When you still watch some video, especially on television, you still see some of these problems coming up. The frames are not played in the correct order or time frame. And secondly, there is no intermediate scheduling between video and audio. Lip synchronization does not work. You see somebody talking, as he's talking, the lips is moving. Then the lip is moving. Later, you start hearing what he was supposed to have said about half a second ago. They are not sequenced together, synchronized together. That is a big challenge in multimedia system. So a correct algorithm, synchronization and sequencing algorithm are normally used that will guarantee everything working very well without any problem. The key issues multimedia systems need to deal with here are how to represent and store temporal information, how to strictly maintain the temporal relationships on playback and retrieval, what processes are involved in the above. Temporal information that just came about that you can use to manipulate whatever is being stored or played. How do you strictly maintain the temporal relationships on playback and retrieval? So data has to be represented digitally. I think an explanation comes up. So many initial source of data needs to be digitized. And this will involve scanning for pictures or still images, sampling for audio and video. Although digital cameras now exist for direct scene to digital capture of images and video, digital cameras are still used. Some people also use their mobile phone, Android phone or iPhone, which has some elements of digital camera inside them. And the data you are going to store is very large, several megabytes, easily for audio and video. Therefore, storage, transfer bandwidth, and processing overheads are very large. Because when you now store this data on your phone, you now want to move it to another phone or on a computer. The bandwidth in terms of transfer will become very, very high. Data compression techniques are now common. And these data compression techniques are algorithms that will pick very large files, compress them, and make them to look very small so that they can fit in through the medium and be moved over your channels of communication. Then you also have the host computer power requirement. I recorded using a low power system. It is going to a higher power system. It will work better. If I now record using a higher power system, it's going to a lower power system, it will be slower. So you have to also think about that. The video may have been recorded using highly capable digital equipment that can move very fast, and the data was compressed with the latest algorithm, and the video quality is very, very high. When it now comes to a lower quality video environment, it will also affect how that particular material is rendered. You will not be able to get the full effect because this thing was recorded using a highly digitized machine. It is now coming to your side now, passing through a lower digitized machine. You will not enjoy it. Take, for instance, those of us that normally play video that is in high definition mode. You now bring it to a television that has a lower definition mode. You won't enjoy the picture quality to be low, to render it low. Storage and management requirements are also there, and the human interface or usability requirements are there. Data storage and management requirements, how do you store the data? How do you manage it? You also have to think about that. The human interface usability requirements, what are those equipments that you are going to connect that will allow you use it well? For instance, it may come up to my own side now. I don't have a good webcam that can record my feature, or I don't have a good monitor that will render it well. That may also affect how I interface with the system. The network latency and throughput requirement, bandwidth may come up. That may also affect how that particular system is now sent to you. Desirable features for a multimedia systems. Very high processing power. Every multimedia system may have the following features that will be desired. High processing power, because you need to deal with large data processing and real-time delivery of media. Multimedia capable file system, a file system that is capable of storing large files, housing them well, is needed to deliver real-time media. When you say real-time, almost as they are recorded, they can be rendered, especially video, audio streaming. Because when you say real-time media, just as you are having a class going on, the class is being beamed to you direct. That means you have a capable file system that can do that. So hardware, software needed could be RAID technology. You can go and find out what it means. Then data representation file format that supports multimedia. File format should be easy to handle, yet allow for compression and decompression in real time. It could compress the file, reduce the size when it is transmitting it. When it gets to where you are going to use it, it can decompress it, open it and expand it so that you can now see the real file and it doesn't affect your storage. Then efficient and high input-output. Input-output to the file subsystem needs to be efficient and fast. So when you are entering data into the file system, it should be very fast. When you are bringing it out, it should be very fast. Very, very fast so that it looks as if you are putting in and taking out almost at the same time. So this needs to allow for real-time recording as well as playback of data. Example, direct-to-disk recording systems. Then you have special operating systems. Not all operating systems can handle large files. So if you are using very old versions of Windows, you'll be surprised that when you put some files on your system, they will not open. So the modern operating systems are special because they allow access to file system and process your data efficiently and quickly. This needs to support direct transfers to disk because immediately you finish recording, it directly transfers it to your disk. Real-time scheduling, it can schedule when to play and it plays it almost immediately. And fast interrupt processing, input-output streaming. They also have storage and memory, large storage units of the order of 50 to 100 gigabytes. Gone are the days when you are buying a hard disk, a system, and you're having 5 gigabytes, 1 gigabyte. Now, everyone is even going up to terabyte, 1 terabyte, 2 terabyte, 500 gigabyte. Why? Because the larger storage you have, the more files you can store. And you also go up for higher memory. You are no longer talking about megabyte again. You are not talking about gigabyte, 2 gigabyte RAM, 4 gigabyte RAM, 8 gigabyte RAM, because the more RAM you have, the more files that can be loaded on your main memory while they are being processed. But the lower RAM you have, it means most files cannot be loaded and played at the same time. So these are just some of the things we need. They also have network support. Client-server systems, common as distributed system, we need them. As common as distributed systems, we need them. Client-server systems, where you have a client, a server, several clients and the server can contain most of the files you want to interact with, and the client can access those files. And then you also have distributed system, whereby systems are distributed across different areas. You have a system here in Benin interacting with another system in Lagos, as the case may be, and they can share files and information among themselves. Then you also need software tools, which are user-friendly tools that are needed to handle media, design and develop applications, deliver media. So when you are talking about Windows Media Player, Boom Player, and most of these modern media players, they are actually software tools that help you to handle media, design and develop applications, and also deliver your media. Because your Windows Media Player can also be used to design, also develop applications, and also develop your media so that it comes out the way you want it. Components of a multimedia system. We have capture devices, which include video camera, video recorder, audio microphone, keyboard, mice, which is mouse, graphic tablet, 3D input devices, tactile sensors, video recording devices, digitizing sampling hardware. All these are combinations. You could have them all together. Sometimes a video camera may have all these things embedded inside it with a keyboard and mouse used to navigate around it. Most of our modern systems have some of these capture devices embedded inside them. They also need storage devices like hard disk to store large amount of data, CD-ROM to store what you can remove, JAWS or zip drive, and DVD to store what you can take away and work on. You need communication networks like Ethernet, token ring, FDDI, intranet, and internet. If you are working within companies, that is within a particular environment, that is when you start talking about the type of network like token ring, Ethernet, and the other, or intranet. But when you are working on your own and you are interacting with people outside, the internet is the most common communication network we will advise you to have. You also need computer systems. Our modern computer systems always include multimedia capabilities. So you have multimedia desktop machine, you have workstation, you have MPEG, video, DSP hardware. Most of these particular technologies are now embedded inside the laptops that you buy. So most of the laptops you buy have appropriate sound and video card with adapters that are added to them. So you also have a graphic adapter, a video adapter added to it, or graphic processing, the processor added to it. Then you also need display devices. Your monitor or your screen needs to be very, very powerful. And so good quality CD quality speakers that can display audio. Then high definition television, SVGA, high resolution monitors, and column printers also help you to display your output in various forms as much as possible. Trends in multimedia. The current big application areas in multimedia, they include one, World Wide Web. World Wide Web is even the biggest application areas in multimedia now. Hypermedia system, which embrace nearly all multimedia technology and application areas and is increasing as much as possible. The World Wide Web contains lots of files, billions of files from different computers all over the world. I think is the biggest multimedia collection, tool collection on Earth today. So there's basically no kind of file you will not find on the World Wide Web. And when you make it an appropriate query, such files will be located from where they are kept and brought out to you. Then you have the multicast backbone called M-bone, equivalent of conventional TV and radio on internet. Most of us are not aware that even on the internet, we have television and radio, especially when you are using, what do you call it now? Your smart television. The multicast backbone is there that helps to drive radio and TV services on the internet. We also have enabling technologies. Enabling technologies developing at a rapid rate to support ever-increasing need for multimedia. You have carrier, switching, protocol, application, coding and compression, database, processing, and system integration technologies at the forefront of this. All these coding and compression, you can code, you can compress. Database, you can find way of storing different files conveniently. Processing, how to process them and bring out the best out of them. System integration,